Hello everyone, thanks very much for joining me on this session. My name is Rendon and I'm a Microsoft MVP with expertise in Azure and currently serve as a pre-sales engineer at Kemp. The content covered in this video will provide you guidance on how to set up the Kemp LoadMaster and instructions on how to configure the HA mode on Azure. In this diagram, we are using the following configuration: 2 virtual machines or VMs that are running a website, 2 virtual LoadMaster, and each of these VMs has a single NIC. Also, we will make use of 2 availability sets. As a quick note in here, by using availability sets, your VMs will be protected from failures that may happen within a data center. This includes hardware failures and Azure software failures. Also, by using availability zones, your VMs will be placed on physically separate infrastructure with no shared resources and will be protected from entire data center failures. Then we're gonna use a Azure load balancer to expose a front-end IP address. The front-end IP address will be used as a Kemp shared IP address to distribute traffic to the respective IP configuration for each website. So let's first understand the Azure Load Balancer core components. First of all, within the Azure Load Balancer components, we will have a front-end IP pool, which is the IP address of the load balancer. It is the point of contact for clients and can be either public or private IP addresses. Then we will have the capability to set up the inbound NAT rules. An inbound NAT rule will forward traffic from a specific port of a specific front-end IP address to a specific port of a specific backend instance inside the virtual network. Then we can configure load balancer rules, which are the ones that tell the load balancer what needs to be done and when. We can also configure the health probes. A health probe is used to determine the health of the instance in the backend pool. You can define the unhealthy threshold for your health probes. When a probe fails to respond, then the load balancer stops sending new connections to the unhealthy instances. And at the very bottom, we have the backend IP pool, which is the group of virtual machines or instances in the virtual machine scale set that are going to serve the incoming request. The following diagram provides a high-level overview of the configuration that we will be doing in this video. We will configure a Kemp LoadMaster in HA mode for Azure, which involves 2 LoadMasters that synchronize settings bidirectionally. If you perform any change on the master node, these changes made to the master are then replicated to the slave node, and changes made to the slave node are replicated to the master. The replication of these settings from master to slave may take a few moments to complete. Also, the master unit is always set as active, and the slave unit can be standby or active if the master fails. However, the master unit is the master and never becomes the slave, even if it fails. So when the master unit comes back up, it is set as active and connections are automatically directed to the master node again. And it is really important that the HA checkport must be set to the same port on both nodes. In this case, we will use the port 8444. Also, you need to ensure that the NSG or network security group rules are properly configured to allow inbound traffic to the LoadMaster. A network security group basically contains a list of security rules that will allow or deny network traffic to resources connected to Azure Virtual Networks. When we set up the LoadMaster on HA mode on Azure, we will leverage the Azure Load Balancer front-end IP address as the LoadMaster shared IP address, or most commonly known as the shared interface, which is shared with the partner unit. This shared IP address is identical for both LoadMaster appliances when we configured HA on premises, but it is associated in this case with only the active LoadMaster at a given time. Now let's go to the Azure portal to start the setup of the LoadMaster in HA mode. First of all, I'm going to create a resource group in case you don't have a previous one. I'm gonna go to resource group and click on create. In this case, I'm gonna name the resource group as PS Kemp HA. I'm gonna use the West US region, and then I'm gonna click on create. Once the resource group is created, then I'm gonna proceed to create the two virtual machines that are going to host the website. I'm going to create a new resource, and I'm going to select the Windows Server 2016 data center. On the basics tab of this configuration, I'm gonna select the resource group that I have previously created. I'm going to provide a name for this virtual machine. I'm going to ensure that I'm using the West US region. Then I'm going to create a new availability set. As for now, I'm gonna leave the same standard DS1 version 2 size, and I'm going to provide the credentials for this virtual machine. Then I'm going to select the inbound ports. In this case, select the HTTP and RDP, then click Next. On the Disks tab, I'm going to change the OS disk type to a standard SSD. On the Networking tab, I'm going to create a new virtual network for this environment. Click on Create New. I'm going to use the following address range: 10.20.0.0/16. I'm going to add the default subnet. I'm going to modify the address range, and I'm going also to add a second subnet, in this case 10.20.2.0/24. Then click OK. Then select the web subnet for this specific server, which is gonna be our host for our web application. Then I'm gonna click on create new public IP. I'm gonna also make use of the standard SQ. Then I'm going to select the inbound ports. So I'm gonna check HTTP and RDP. I'm gonna leave the default load balancing configuration and then click on Next Management. On the Management tab, I'm going to enable the boot diagnostics and store those diagnostics on a new storage account. Then click Next. I'm not adding any extension on this virtual machine, so I'm gonna click Next. On the Tags tab, I'm going to set the environment name. In this case, I'm going to set value LoadMaster HA demo. Then I'm going to click on Review and Create. Once the validation process is done, I'm going to click on Create. Then proceed to replicate the same process for the second virtual machine, that it's going to be our second host for the web application. Now I will proceed to create the second virtual machine. Click on Create a Resource, select Windows Server 2016 Data Center. Then on the Basics tab, I'm gonna make use of the same resource group previously created. I'm going to name this virtual machine. Select the West US region. On the availability options, I'm going to select availability set, and I'm going to use the availability set previously created. Then I'm going to set up the credentials for this specific virtual machine. Same as before, I'm going to select the HTTP and RDP. Then click Next. On the Disks tab option, I'm going to select the OS disk type as standard. Then click on the Networking tab. I'm going to make use of the same virtual network, and I'm going to assign this specific virtual machine to the web subnet. Then I'm going to create a new public IP address for this virtual machine. Again, I'm going to select the standard SQ. Then click on the next tab, which is Management. Similar to the previous virtual machine, I'm going to enable boot diagnostics and store these diagnostics on the previously created storage account. Then click on Next. I'm going to skip the advanced configuration since I'm not adding any extensions or any specific configuration. Then I'm gonna make use of the tags. I'm gonna provide the name related to the environment and value, which is LoadMaster HA demo. Then click on Review and Create. Once the validation process is done, click Create. Once the deployment of the virtual machine is complete, let's go to the resource. In this case, I'm going to enable the IIS role on this virtual machine. So on the virtual machine operations options, I'm going to select Run command, then select Run PowerShell script. I'm gonna execute this script that will enable the web server feature. And I will do the same for the second virtual machine. Once the second virtual machine, then I will go to the operations options and select Run command. Then select Run PowerShell script and execute the same script as before. Let's go to the Azure portal and create the Azure Load Balancer. Let's click on Create a Resource. Then look for the Load Balancer. Click on Create. Now I will use the same resource group previously created, and I'm going to name this Load Balancer. I'm going to select the West US region. For the sake of this demonstration, I'm going to use the public type of the load balancer, and I will also select the standard SKU. Then I'm going to select create new public IP address and provide a name for this public IP address. Then I'm going to click on next. On the tags, I'm going to select environment and the same value as before. Then click review and create. Once the validation is done, click create. Once the deployment is complete, let's go and verify that we have enabled the two web servers on the two virtual machines. Let's go to the first virtual machine. I can see that the role has been enabled. Let's go to the overview of this virtual machine. So I will copy the public IP address, open a new tab, and we can verify that the AIS is up and running. Now let's verify the second virtual machine. We can also review. So as we can see, the web server role is also working as expected. Let's go to the overview of this virtual machine, and on the overview of the second virtual machine, let's copy the public IP address, open a new tab, and we will see that the web server is up and running. Now we will proceed to create the first master node of the Kemp LoadMaster. Now let's go and create the first node of the Kemp LoadMaster. Let's go and create a new resource, and we will look for the Kemp LoadMaster on the Azure Marketplace. Then I'm going to select the LoadMaster offering. For this demonstration, I'm gonna make use of the BYOL license, then click create. On the basics tab of the LoadMaster, I'm going to select the previous created resource group. Then I'm going to provide a name for this LoadMaster. I'm going to select the West US region, and under availability options, I'm going to select the availability set. In this case, I'm going to create a new availability set. So provide a name for this availability set, then click OK. The LoadMaster requires at least 2 virtual CPUs and 2 gigs of memories. So for this demonstration, I'm gonna make use of the standard 83. Then I'm going to select the password as the authentication tab. It is important to use val as the principal username, and then provide a password for your LoadMaster. Then click next. On the disk options, I'm going to select the standard HDD and then click on the networking tab. I'm going to use the previously created virtual network, and in this case I'm gonna select the default subnet for this LoadMaster. Then click on create new public IP address. In this case I'm going to use the standard SKU and then click OK. The LoadMaster by default has some pre-configured network security group rules. So at this moment, I'm not going to modify anything until we have created the HA. Then under the load balancing options, I'm going to place this virtual machine behind an existing load balancing solution. So in this case, you should be able to see the load balancing options and select the Azure Load Balancer option. Then select the load balancer previously created. You need to select a backend pool. So in this case, we will create a new backend pool. This will be the Kemp HA backend pool. Now we will move forward into the management tab. In this case, I'm gonna also enable boot diagnostics on the same storage account and then click next. I'm not adding any advanced configuration, so click next on the tags tab. Now I will assign the same name and value, LoadMaster HA demo, for the resource, then click on review and create. Once the validation is done, click on create. Now let's create the second LoadMaster. Let's go and create a new resource. Look for Kemp on the Azure Marketplace. Then select the LoadMaster. Then I'm going to use again the BYOL license. And then click create. On the basics tab, I will select the resource group previously created. Then provide a name for this virtual machine. Then I'm going to select the West US region. Under the availability options, I'm going to select availability set and select the previous availability set created. Then select the password as the authentication type. Remember to use val as the principal username. Then click next on disks. Here I'm going to select the standard SSD and then click on the networking tab. In the networking tab configuration, I'm going to select the previous virtual network created and the default subnet. Then I'm going to click on create new public IP address. In this case, I'm going to select the standard SKU, then click OK. I'm not going to change any configuration for the NSG, and on the load balancing options, I'm going to place this machine behind an existing load balancing solution. Then under load balancing options, select the Azure Load Balancer and select the load balancer previously created. Then I'm going to select the same backend pool previously created and then click on the next management tab. In here, I'm going to enable boot diagnostics on the same storage account and then click next. I'm going to skip the advanced configuration and then click next. Now I'm going to assign the tags, name environment, and the value LoadMaster HA demo. Then click on review and create. Once the validation process is done, let's click create. Now that we have provisioned the 2 web servers and the 2 LoadMasters, let's go and access to the first LoadMaster. Let's go to this resource. Now let's go to the first LoadMaster under the networking options and copy the NIC public IP address. So go to your browser and Google access through port 8443. Click on details, go on to the next web page. and agree to the license. So in order to license your LoadMaster, you need to have a Kemp ID. So if you don't have a Kemp ID, you can create one through this URL. Once you have your Kemp ID, you can use it to license your LoadMaster. Type your credentials and click on License Now. You will see this temp license. Select this checkbox and click on Continue. Now we have installed the trial license. Now click Continue and I will access to the LoadMaster. Now we have the LoadMaster with the trial license active. Let's go and perform the same licensing process for the second LoadMaster. Let's go to the second LoadMaster, then go to the networking option under settings and copy the public IP address. Open a new tab and access through port 8443. Click on details, go onto the web page, and then click on agree on the licensing page. Then again use your same Kemp ID to license your LoadMaster. Then select the temp license type. Click continue. Now our trial license has been installed. Now click continue. And now you should see the interface of the LoadMaster. Until this point, I have created 2 web servers and 2 Kemp LoadMasters. Also applied a license to both LoadMasters and created the Azure Load Balancer in front of these 2 LoadMasters. Now we will perform the HA setup. Let's go to the first LoadMaster. Now we will set the rules on the load balancer to perform the redirection to the management ports and to the virtual services. In the overview of the Azure Load Balancer, we should be able to see. In the overview of the Azure Load Balancer, you should be able to see the backend pool associated to the 2 instances of the LoadMaster. And you should also be able to see the public IP address associated to the Azure Load Balancer. Now we still need to set the help probe, the load balancing rules, and the NAT rules. So let's start to set up the help probes. Let's go under settings, select help probes and click on add. Now provide a name for the help probe, in this case PSBLM HA help probe. Select port 8444. Then provide the port 8444 and click OK. Go and create the inbound NAT rules. Under settings, select inbound NAT rules and then click on add. On this inbound NAT rules, we're going to create the following rules: 2 rules for the master node and 2 rules for the slave node. One rule is basically to access to the management console or the through port 8441 and then have access through SSH as well. So let's go back to the inbound NAT rule and create the first one. So this is gonna be our first rule. We're gonna use the front. I'm going to use the load balancer front end IP address. Then select the port 8441. Select the target virtual machine, which is going to be the first LoadMaster. Associate the network IP configuration. and select the custom port mapping. In here, I'm going to select the target port 8443. Then click OK. Now let's go and create the second rule for the SSH access. Let's click on Add. Provide a name for this rule. Then we would use port 221. Target the master node. Associate the network. Associate the IP address. Select the custom port mapping, and target port it's going to be 22. Then click OK. Now let's go and create the third rule, which is gonna be the access to the let's click on Add. Let's provide a name for this rule. Port will be 8442. Target virtual machine, it's going to be the second LoadMaster. Associate the IP address. Select custom port mapping, and target port it's going to be 8443. Then click OK. Now add the last rule, which is going to be let's provide a name for this rule. Select the port 222. The target VM is going to be the slave LoadMaster. Associate the IP address and select the custom port mapping to target port 22. Then click OK. We have added the backend pools, the inbound NAT rules, and the health proofs. So we still need to configure the load balancing rules. In this case, I'm going to go and add a new load balancing rule. So this load balancing rule, it's basically to allow traffic through a specific port. In this case, let's create the rule for to allow traffic through port 80. So we'll set the port 80 and also the same port for the backend. Then we will target our backend pool, which consists of the two LoadMasters, and associate this health proof to the HA of the LoadMaster. Then click OK. We will also add the rule to perform the health check on the port 8444. So in this case, the load balancing rule will be specifically to the port 8444. Select the port 8444 as well as for the backend. and we will use the same help proof. Then click OK. I'm going to also add a help proof for port 80. So in this case, let's call it just help proof. Then click OK. Just to verify on the load balancing rule, to allow traffic to port 80, we need to ensure that the backend port is 80. We are reaching to the backend pool, which are the two loadmasters, and the help proof should match the port 80 rule previously created for the help proof. Then click Save. So now if we go to the help proofs, we have a health proof for port 80 and the health check proof for port 8444. In this case, I'm going to set the health proof for the 8444 through the HTTP. Then click Save. So let's recap the configuration for the Azure Load Balancer. The Azure Load Balancer will be now the shared IP address to access to the master and the slave nodes. So we have the backend pool, which consists of the two load masters. We have two health proofs, one to allow traffic to port 80 and the other health proof for to perform the health check on the nodes through port 8444. We have two load balancing rules as well, and 4 NAT rules, basically to access to the load masters. So if we go to review all the configuration, we have the backend pools, which are the two VLMs or the virtual load masters, which have also a private IP address. Then if we go to the health proofs, we have two health proofs, one to allow traffic through port 80 and another health proof to basically perform the health check between the master and the slave nodes. Then if we go through the load balancing rules, we have the load balancing rule to allow traffic through port 80 and the load balancing rule for the health check and the load balancing rule to perform the health check on the backend pool. Then if we go through the inbound NAT rules, we have configured the inbound NAT rules per node, 2 for the master and 2 for the slave. So now let's try to access to the load master node through the Azure Load Balancer IP address. So let's copy this public IP address of the load master and we will access through the port 8441. As you can see, I'm being redirected to the master node. Click on System Configuration and select the Azure HA parameters. This this will be the master node, so we will select the master HA mode, and under the partner name IP address we will use the public IP address of the second LoadMaster. Then click on set partner name. Now we will use the 8444 port to perform the health check. Then click on set health check port. Now let's go to the second LoadMaster. Go to System Configuration, select Azure HA Parameters, and this will be the slave node, so I will select slave HA mode. Click OK. Now we will place here the partner name or IP address from the primary node or the master node. So let's copy here the master IP address, then click on set partner name. Then same here, we will use port 8444 for the health checks and click set health check port. Now go back to the master node and now go to System Administration, select System Reboot and reboot the virtual machine. We'll perform the same on the slave node. Go to the System Administration menu, select System Reboot, and then reboot the virtual machine. Since we enabled the port 8444 for health checks, we need to perform those changes at the network security group rule level. So let's go to the Azure portal, into the networking options, click add inbound port rule, and in here I'm going to add so in the inbound security rule, select provide the 8444 and modify the name to port 8444 and click add. And I will do the same for the slave node. So in the second LoadMaster, let's go and add an inbound port rule. Same as before, set the destination port range 8444 and the name for the security rule. Then click add. Now you can see that the port has been added to the NSG rules on both on the master node and also in the slave node. Also, we will add a port 80 to allow traffic through the LoadMaster. Click add. Then we will do the same on the second LoadMaster. Add inbound rule. Port 80. So now let's go and access to the LoadMaster, the master node, and the slave node. Now let's recap the HA configuration for the LoadMaster on Azure. So we have provisioned 2 LoadMasters on Azure. If I go to the virtual machines, I can see the 2 LoadMasters that I have provisioned. And now that we have configured the load balancer, we should be able to access to these load master and slave nodes through the Azure load balancer. So also summarizing the configuration for the Azure load balancer, I have a backend pool associated, which are the 2 load masters, 2 health probes, one to allow traffic to port 80 and one for the health checks through the port 8444. Also, I have 2 load balancing rules, same for the health checks and to allow traffic to the load masters, and 4 inbound NAT rules, basically to be able to access to the master and node slaves and management console through this public IP address. So if I try to access to this IP address now using port 8441, I should be able to reach the master node. So as you can see, I'm able to access to the master node. Now let's review the HA setup. Now let's review the HA mode setup. As you can see, this specific LoadMaster now it's the master active node. If I go to system configuration under Azure HA parameters, I can see that I have set the partner name or IP address of the second LoadMaster network interface card for the virtual machine. So now if I go to the slave node using the same Azure Load Balancer IP address, but now accessing through port 8442, I will be accessed to reach the slave node. As I mentioned at the beginning of this video, only one node is actively passing traffic. So as you can see, if the H mode is effectively passing the health check through the port 8444, so you should see that the slave node is in standby and you should see a limited interface on this standby unit. So now let's go back and try to add the web server on the LoadMaster. So now let's configure the application in the master node. I will access the master node, which is actively passing traffic. So I will go through virtual services and click on add a new virtual service. As you can see, Azure automatically populates the virtual address field, which is associated to the network interface card. In this case, the virtual IP address is 10.20.1.4. So I'm going to provide a service name, which is in this example the IIS. Then I'm going to click on add this virtual service. Now I'm going to add the real server, which is the virtual machine where we enable the web server role. So for that, I'm going to click on add new. And I'm going to place in here the public IP address of the web server. So I'm going to place the real server address through port 80 and add this real server. Now I have added the real server. So let's go to the view and modify services option. The LoadMaster automatically will perform the health checks, and as you can see, the server is up and running. So now if I access to the Azure load balancer public IP address through port 80, I should be able to see the IIS screen. As you can see, we are accessing to this web server within the Azure environment through the LoadMaster. Now let's add the second node, the second web server, to the same virtual service. Let's go to modify this virtual service. Let's go to add a new real server. And now I'm gonna place the real server address of the second Windows Server machine, virtual machine. I'm going to click on add this real server. So I have added the real server through port 80. So now the LoadMaster in HA mode is actively distributing traffic across both web servers. So for that, to verify that, I'm going to go to the statistics in real time. I'm gonna see that we have a virtual IP address with a couple of connections through this virtual service. So I'm seeing that the last test went through to the first web server. So now I'm going to disable this real server to check that if I access through the Azure Load Balancer public IP address, I'm gonna be redirected from the LoadMaster to the second web server. So let's go to View and Modify Services and disable the first web server. Now go back to View and Modify Services. Let's wait for the LoadMaster to perform the health checks. So the LoadMaster is telling me that it's actively passing traffic to the second web server. Now let's go to the Azure Load Balancer public IP address and access through port 80. I'm being able to access to the web server. Now let's go to the statistics in real time. Let's go to real servers. And now you can see that the LoadMaster in HA mode is actively passing traffic to the second web server. So as a summary on this video, we reviewed how to deploy the Kemp LoadMaster in HA mode. We went through the configuration step by step to spin up 2 web servers, then provisioned the Azure load balancer and also provisioned 2 load masters. Then we configured the Azure load balancer with the inbound rules, the load balancer rules, the help ropes, and the backend pools. We also reviewed how to perform the configuration for the HA mode within the LoadMaster, and also how to configure a virtual service with the 2 web servers. So this completes the video on how to set up the LoadMaster in HA mode on Azure. Thank you.